Hey everyone, welcome to Module 7 of Code at GWA. So today we'll be going over while and for loops, as well as how to increment integers within them, and how to use Boolean operators within them. So let's get started. A loop essentially loops or continuously repeats the code nested within it until a certain condition has been met. This specific condition depends on the type of loop. So in the case of a while loop, it relies on the Boolean operator to the right of it. So if the Boolean object of the while loop condition is set to be a constant true, not a variable true, then obviously the while true loop will continue to loop forever. In other words, this is a forever loop. There are ways to get out of this loop, and that is using the function break. So here are some examples of a forever loop and the ways in which break statements can be used to exit these loops. Just observing this, it will obviously print this, and then I'll break out of the loop. So it'll only print this once instead of printing it forever. So as you see here, it's only printed once. This example here is not realistic. I mean, there's no reason to do this, just to print one thing and then break. So this is one use of it. If you want to make something like a guessing game, you could use a while loop. So if you want to have an infinite number of tries to guess a number, then you might want to use this. So as you see here, the input is the number that you'll guess, and you have to set the number, or the number that you have to guess beforehand. And once you've made your input, if it's the right number, or if, in this case if it equals 5, then it'll print the statement here. It'll tell you that your guessed number was correct, and it will break from the while loop, so it will stop repeating and the code will end. But if it's not the correct number, it will tell you that the number's not right, and you'll have to keep on guessing until you get the right one, because there's no break in this else statement. So if I put 5 here, it'll probably exit. It should exit immediately, as you see here. But if I put something like 2, it won't, and I'll have to keep on guessing until I get it right. So this use of a forever loop is essential for many programs. For example, if you have a game, you don't want it to exit immediately if you haven't made an input that it doesn't expect. So if you have a while true, it's going to keep on running, and it'll only do something if an expect. So as you see here, if I put something like that doesn't make any sense, continue to run until I put something that expects like Sunny. So let's use this function of forever loop in our code here. So here we just pretty much have to continue to ask for a valid name, and when we do, then we have to greet whoever this name in a print statement. So yeah, go ahead and do it. One thing to note when you make while loops is that they function similar to any other form of nested statement, so like a conditional or for loops, which we'll get to later. So what I mean by that is you have to have the standard semicolon syntax after the Boolean condition, and then to indicate that the code within it is nested, you have to indent it. Okay, so this code is very simple. You pretty much enter the while loop straight away. You can initialize the name or whatever the variable, whatever you want to call the variable outside of the while loop, but I mean I just did it here, it doesn't matter. And I've initialized it as the input. If the input is an alphabetical string, then I'll do the greeting and break out of the loop. But if it's not, then I'll keep on asking you for a name until I do get a valid name. So if I get someone called, it's going to print this, but if I print, I mean this is still gibberish, but it could be a name, you never know. And there you go. Well, I did make a mistake here. It should be this, because there's a space there. Yeah. So another concept I'm going to go over is incrementing and decrementing. So usually if you want to change a variable, perform an operation on it, you would do something like this: votes equals votes plus 1. But you could also do it like this: votes plus equals 1. So when you do this, you're recognizing that, hey, I want to edit this variable here, but at the same time use the variable within the equation itself. So this is essentially the same thing as this. This works with any of the operators. So if you wanted to subtract, you could use minus equals. If you wanted to multiply, it would be asterisk equals. If you wanted division, it would be / equals. Here, votes equals 3, you print 3, and you get 3. This should be 4, 4. This is pretty much the same thing as doing this, but you're adding 2, not 1. So this would be 6, and you're subtracting 1, so you're getting 5. And again, votes is updating every time you do this. Because normally if you just did votes minus 1, then votes wouldn't update. It would just return, well in this case it would return 5, but votes wouldn't update and equal 5. So in this example here, there's a finite number of seats, and this will ask you for what type of seats that you want. And if you continue to ask for seats, and if the threshold has been met, it'll exit the loop automatically. Even if... So in this code here, there's a finite number of seats, and this code checks if there's still seats left. So if you continue to ask for seats, the number of available seats will continue to go down, and once there are no available seats left, it will exit the loop. Alternatively, there's an exit condition, so you can exit straight away if you don't want to add any more seats. And since the number of seats is 4, this should return us the seats are full statement, and it'll tell us the total number of seats once it exits the while loop, as you see here. But let's say we only want to input 3 seats. So let's say soft, hard, soft, and then exit. It'll exit preemptively, and it will still tell us these. So this task pretty much combines the above concepts. The while true loop is necessary to continue asking for a password until your chances are up. And to keep track of how many chances you have left, you need to use the incrementing or decrementing concept. Okay, so this code is fairly straightforward. I've initialized password, hint, and chances outside of the while loop. Once you enter the while loop, it first checks if you've made 2 attempts. If you have, it will print the hint. Regardless, it will then ask you for an input. If your input is equal to the password, it will tell you that it is, and it will exit the while loop. But if it's not, it will tell you that it's not, and the number of available chances that you have will go down. If your chances are 0, if your attempts are, like if you have 0 attempts left, then it will tell you that you have 0 attempts left, and you'll be removed from the loop. So if I get everything wrong, it will kick me out. But if I get everything right, if I get it right, let's say on my 3rd attempt, then I'll be able to get in. So far, I've only been using a constant true Boolean object as the while condition, but you can also use operators, Boolean operators, because they also return Boolean objects. So you can, well, in other words, you can pretty much use anything that returns a Boolean object. But in this case, we're just going to be looking at comparison operators. So let's look at this code here. The rocket will lift off in 5 seconds. Obviously, there's no timer in this code. You have to upload a module into this, and we're not going over modules. But once the liftoff is equal to 0, the while loop will be broken, and it will print this. But so long as the liftoff is still greater than 0, it will continue to print this. Oh yeah, right, sorry. Liftoff is not a string. Okay, so in this task we have to identify an error. It's not a syntax error, but rather a logic error. I think it's fairly obvious, but if you haven't noticed already, count here is 1, and the condition for the while loop to be active is that count has to be greater than 6. 1 is clearly not greater than 6, which means you have to flip this. It should do this 5 times now. Yep, so 1, 2, 3, 4, 5. So the next loop that we'll be going over is for loops. They differ from while loops as they don't have a conditional object that's needed. They rather rely on iterables. Once the iterable has been iterated through, like everything has been iterated through, then the for loop will end. Um, I'll go into more detail into iterables in module 8. But for now, all that you need to know is that an iterable is something that has multiple values within it that can be called using something called an index. And you'll kind of see what I mean once we get into these for loops. So when the for loop iterates through something, it takes one value of an object and returns it. And this is its local variable that it will always have. The local variable, or the name of it, will be the name that you put next to the for loop here. So in this case, the local variable would be called x, but if you called it sandwich, then the local variable would be called sandwich. In for loops, range is a commonly used function because they return an iterable and they're really easy to use. So to elaborate, a range function will return, as you would guess, a range of numbers. The start of these range of numbers is indicated by this. So here it would start at 3, and the end of them is the stop, -1. So it doesn't count the stop. So in this case, the start would be 3, the stop would be 8, and the stop would be 2, meaning it would start at 3, it then move on to 5, because you add 2, since that's the step, then move on to 7, and then it wouldn't give you anything else because 8 is the highest step that you can, 8 is the highest value that this range can return. And since 7 plus 2 is equal to 9, and 9 is greater than 8, it will not return 9. So it will just give you 3, 5, and 7. Like while loops, you can also use breaks to exit for loops preemptively. This is pretty useful if you're iterating through something that's quite large, like a large list or a large string. But otherwise it's not that useful in small iterables. So going into a little more detail about range, you don't need to put all the parameters. If you just put 1, it'll give you the maximum. So in this case, the maximum would be 4, and the start will always be considered to be 0. So 0 is the default start. If you put another parameter in, the first one will be considered the start, and the last one would be considered the stop. But the step is also will always be considered to be 1 as the default. If you don't want the step to be 1, then you have to specify by adding another parameter here. So this code will count to 4, sorry, because although count is 5, remember that range uses the maximum -1 as the true maximum. So when we run it, it should print 1, 2, 3, 4, and then done. As you see here, I've got the 0. Remember that the 0 is always the default minimum. So this code is quite complex compared to the previous ones. Pretty much you have to make a function that takes 4 parameters: damage, defense, chance, and hit count. You then use these as inputs to calculate the total damage dealt to an enemy using this formula here. And then your output is whatever the result of this formula is. Your hit count and mischance are dependent on the random.range function. Random.randRange. Don't worry too much about what this is. All you have to know is that the random thing that you see here is called a library or module. It pretty much imports set functions that we can use without coding ourselves. This random.seed allows you to use to generate random numbers, or pseudo random numbers, I should say. And the random.range function here is like the range function in the sense that it returns a random number within the specified range. So let's say that I want to generate something within 30 and 60. I'll do that. It also has a step like range, but in this case, we don't really need a step. Try to figure out how to do the hit count and mischance yourself. If you're struggling to do that, then just skip ahead a few seconds and I'll show you how to do that. Sorry, one thing that I forgot to mention is that don't copy and paste this formula because it's not going to work exactly the way it's intended, because if you miss, then every hit will miss, which is not what you want. You want one specific hit to miss. So as a hint, use the for loop for that. each hit should be considered a different attack, and then you should sum those attacks to get the total damage at the end. Okay, so this is my code. I did a slightly different way to calculate mischance and critical chance than was listed here, so I'll go over that now. So yeah, I imported the library and I started a random seed. I then initialized the different variables that we need to calculate the damage. If this is a game, then these would already be saved beforehand in some other operation. So that's why I've stored them as variables and have not taken them as inputs. Here's a function. Total will be the local variable that accrues all the total damage, and then once all the damage has been calculated, it will return total. So this is a for loop based on the number of hits that you have dealt to the enemy. The for loop will loop that many times. So in this case, hit is 5, so it will loop 5 times, which means the total will add up 5 times. Here the damage is 10 and defense is 5, so this will always be 5. Now this is where it gets a little complex. So what I did here was, since the miss and crit chance were percentage based, meaning they're a value between 0 and 100, I used a random range from 1 to 100. And then I did 200 minus the mischance. So let's say the mischance is 20. 200 minus 20 is 180. Meaning if you get something that's 80 or higher, then it will miss because 180 minus 80 or higher, 180 minus something greater than 80 will result in something that's less than 100. Once you divide something that's less than 100, it will give you a decimal. And since with the int function, the int cost, it always rounds down, so this will be 0. This is done in a way so that the 180 here, so like the 200 minus mischance, the 180 here lines up with the random here. So obviously I need to get an 80 or higher, or 81 and higher, which means that there's a 20% chance of getting that, since there's 20 values that are greater than 80. Pretty much the same logic here, except I've done it with crit chance, and instead of doing, and I also added a +1 to it, because the crit chance should not have the opportunity to give you 0. It should only give you the opportunity to multiply by 2, or if you don't get a crit, multiply by 1. Hence why I put the +1, so there's no chance that it can be 0. It can only be 1 or 2. So once you factor these in, it will return the total once the total damage has been calculated. Note that the highest theoretical value they can get from this would be 50, because this will always be 5, and if you always get a crit for every hit, which is 5 times, then you get 10 damage per hit times 5 would be 50. So knowing that, we can run the code. So we got pretty lucky here. We either hit 4 times and got a crit every time, or a variation of that. If we keep on running this, then you'll notice that it'll always vary, but it'll never be greater than 50, because that's the theoretical maximum. So as you see here before, we got pretty lucky. We got 50, the last one. But yeah, it's pretty neat. Obviously, continuing to run it won't do anything. But if you apply this to a game or something, this would be pretty crucial. So let's move on to strings and how they can be iterated through. So strings are iterable, meaning they have different elements within them that can be called using something called an index. And because they're iterable, you can use them in for loops. So as you see here in this example, we have this code. And the purpose of this code is to extract any alphabetical character within it and use that to find whatever the deciphered code is. But since it's iterable, we can use a for loop to go through each character within this and check if it's an alphabetical character. And if it is an alphabetical character, we can then add it to the deciphered code variable that we've initialized here. And once we've gone through the whole code, we can then print the final result. So this is essentially what is happening here. In this case, a local variable is car or character, and this is the standard syntax for if you want to take an element out of an iterable. I mean, as you see, I didn't really mention it before, but here in range you also use in. So in for loops you always have in to indicate that this variable here is iterating through each element of whatever this is. So it then checks for every iteration if the character is an alphabetical one. If it is, then it will add it to the decipher code. If it's not, it'll just ignore it. So let's see what happens. Wow, would you look at that? So let's look at task 5 now. This one is fairly simple compared to the damage calculation one, but so task 5 is fairly simple compared to the damage calculation one. The steps are pretty self-explanatory. If you want to see an example of it, then here it is. So you input the number of periods you have, then you have to input the subjects. Okay, so here's my code. First of all, I got the subjects as an input, and I allowed for commas and spaces to be used to separate the subjects. And then I initiated 4 variables: period, subject, skip, and count. This period just keeps track of what period the subject is. So pretty self-explanatory. Subject is a container for the strings pertaining to each subject. Once a subject has been printed, it will empty out and concatenate the next subject. Skip checks to see if it needs to skip anything. So in the case here, since it's a comma in space, it will not skip the first comma, but it'll skip the second space because it's already identified that there's a gap between the two subjects. And finally, count is just there for the last subject. The way I've coded this is that it splits up the subjects according to the spaces in between them, but obviously the last subject doesn't have any space after it or comma after it, so it won't print the last subject. So I need the count in order to register that I've reached the end and that this last subject needs to be counted. There's an easier way to do it. It's a lot easier, a lot more efficient, but we'll be learning that next module, and it's got to deal with indexes and elements, that sort of stuff. So first I'm printing the schedule, as you see here, and then the for loop begins. I'm iterating through the string that's inputted here. If it's not a space or comma, i.e. if it's not a separator, then it will add that letter or character to the subject string, and it will just tell the code that the upcoming character is not one that should be skipped. It then checks if it is a separator. The reason why I've not done elif is because also because of the last subject. If it did elif, then it would ignore this and go straight to count, and then go out of the loop, and it wouldn't print the last subject as a result. Yeah, this checks if it's a separator or if it's the last subject. As you see, count equals len of subjects. Len of subjects, let's say it's 30. If count equals 30, then that means it's on the 30th character, which is the length of the string, meaning it's on the last character. So if one of these are true and skip is false, then it will print the subject as well as the period, and the period will increase because obviously moving on to the next period, and then skip will be set to true because the next one after that will be technically a skippable separator, and the subject will be emptied because a new subject needs to be made for the next period. Then after you exit that if statement, the count is increased by 1, so you can keep track of where you are in the string. So let's do some examples. I'm just going to take this as one. So as you see here, it works perfectly, kind of like this. But let's say I use spaces instead of commas as a separator. So it still works even if it's space, and then even if I put a comma. Let's see, it's English. So even a comma, it also separated properly, and it works with any number of subjects. So that's how I would do it. Again, it can be a lot more efficient if we use indexes and that sort of stuff. So that's the end of this module. Thank you for watching. Again, if you have any questions for Suraj and I, then please let us know. If not, then we'll look forward to see you in the next module. See ya.